Welcome to Sairam Tribuli YouTube channel. Let us discuss subject code is 18E56, that is high voltage engineering. It's a branch of engineering. It's a branch of branch area of power system engineering. So in that we have a high voltage engineering include transmission, distribution, generation also, right? So for example, I'll tell you how the high voltage is transferred from the power station to the consumer side, right? So there is a generating station, 11 kV generated, again 130 33 kilovolts or 66 or 110 kilovolts. Again this transferred into transmitted into 11 kilovolts. Again it is converted into required voltage level, right? So high voltage engineering subject. So in the first module we are going to discuss uh, conduction and breakdown in gases, right? So conduction in the sense, if suppose a high voltage conduction occurs, if suppose spark occurs, I think you might have seen in the high voltage flashovers in the transmission lines. If suppose high voltage occurs in the transmission lines, it is connected with the trees and whatever it may be, it's like a flashover occurs. So that's like a conduction, right? And breakdown in gases, so instead of that is a air, right? So if suppose fault occurs in the transmission lines, air is a working media, and if suppose here there is a gases is present, so in that so many inert gases or SF6 gas we are going to discuss now. So electric field stresses. So electric field stress, everybody knows, if suppose conductor carries a current, produces a circular electric field as well as magnetic field. So there is a movement of electrons. If suppose, for example, I'll tell you, if suppose high voltage occurs, if suppose a tree is touches with 33 kilovolts transmission lines or 66 kilovolts transmission lines, what happens? So it looks like a stressing in the field, electric field. So jumping off electron, jumping off this one movement of electrons, right? So introduction part in a mechanical design, criterion for a design depends on the mechanical strength of the material and the stresses that are generated during the operation. So whatever the stress of operation, or if suppose something happened in the breakdown material, so it depends upon the strength of also. Same high voltage applications and electric strength insulating materials and the electric field stresses develop them important factors. Insulating materials in the sense like insulators we are using in the transmission lines also, even though in the transformer also, everywhere we are using insulators. So that strength also we are going to check, right? So the electric stress to which an insulating material is subjected to is a numerically equal voltage gradient and is equal to the electric field intensity. Electric field intensity is the electric field per force or stress creating inside the whatever the media. And also we have a number of insulating materials, class YA, EBE, like that. Will be there. So gases and insulating media. So the simplest and most commonly found electric are gases, everybody knows, and most of the electrical apparatus use air or the insulating media. Air is readily available, so air is a insulating material. Few other gases, electrics, are nitrogen, carbon dioxide, diffusion, sulfur, hexafluoride. SF6 also will be there. So for gases. So when the applied voltage is low, small current flows through the insulating, retain its properties. See, if suppose the voltage is low, so nothing will happen, and if suppose breakdown occur also, it will retain. If suppose the voltage is large, what happens? Current will be flowing in the insulating materials also increases. What happens? So there is a breakdown occurs or something. Damages will occur. The maximum voltage applied to the insulating at the time of breakdown is called as a breakdown of voltage, right? So the buildup of high current in a breakdown is due to the process is known as ionization. So ionization process will be there, right? So movement of ions, electrons from higher level to lower level, or movement of ions from one level to another level, or recombination take place. That's ionization. At present, two theories are present, which can be explained the mechanism breakdown and the different conditions: Townsend's theory and Streamer's theory. Townsend's theory is very important for ionization of gases. So ionization of process also depends upon the various physical conditions. So gases like pressure, temperature, yeah, everybody knows, right? So gases, I think in the PU standard, PU classes we discussed, Bayes law and Charles law. There, so PV is equal to RT, or PV P1 V1 is equal to P2 V2. So it depends upon pressure, temperature, nature of the electrode surface, solubility, initial conducting particles. So these are the parameter depends. So next is a collision process. The types of collision. The electrical discharge is normally created from unionized gas by collision process. Right. This process occurs mainly due to collision between charged particles and gas atoms or molecules. These are two types: electric collision and inelastic collisions. So types of collision: elastic collision. When they occurs, no change takes place in the internal energy of the particles, but only their kinetic energy gets redistributed. So electrons are very light in weight as compared to the gas molecules and are accelerated due to electric field, right? When they collide with the gas molecules, they transfer only a part of their kinetic energy. Types of collision: elastic collision, and electrons gain very high energy and speeds than the behavior of gas ions, and the electrons plays a major role in such a type of collisions. Electrons will be there everywhere. Types of collision: inelastic collision, this one. So here internal changes in energy take place within the atoms and molecules at the expense of total kinetic energies and the colliding particles. The collision often results in a change in the structure of the atom. All collisions that occurs in practice are inelastic collisions, right? So mobility of ions and electrons. Electrons force on an electrons where ions of charge E is equal to with the resulting accelerating being E per meter. The drift velocity of ions W is proportional to the electric field intensity E and may be expressed as W is equal to mu I into E. Mobility of ions and electrons. From the kinetic energy theory, the electrons drift velocity W is given as the equation is like this: E by 3 ma square d by dc on c square, where 1 is the equivalent means free path of electrons with a speed c. Okay. Next we have a diffusion. When the particles possess energy which is exhibit the random motion. I mean diffusion like this in the sense it's a diffusing characteristics. I mean like process of energy which is exhibiting random motion are distributed unevenly through the space. Then the tend redistributed themselves uniformly throughout the space. The process is known as a diffusion. Right. So diffusion and mobility result mass of motion described by the drift velocity caused either by unbalanced collisions forces or by electric field itself.